All right, thanks everybody for joining us today. We're going to talk a little bit about making big data feel small. And to start this out, we're going to do a 4-part history lesson that walks us into how we got to where we got to. The first thing we're going to talk about is the history of big data. Then we're going to talk about how that brought us to kind of DuckDB and what it does. Then we're going to talk about where this takes us into DuckLake and data lakes. And then lastly, what that means for you as a practitioner using DBT. Let's do some quick intros. I am Jacob. Hello, everybody. I work at MotherDuck in DevRel. You may know me from the things that are on the slide, but for those of you that don't, I started my career actually in accounting. And that means to me everything, a database is a ledger, right? A transaction is a journal entry. That's how I just think about things. Sorry, you have to deal with that if you're dealing with me. But the through line here that led me into data is really a lot about accounting is adding numbers and counting them on a time series. And if that sounds a lot like data analysis and like data science, that's because it is. So that's kind of how I got to where I got to. Started working obviously on Excel and moving my way into things like SQL Server. And then now enjoying my time working on OLAP database, which is DuckDB and MotherDuck.
Sweet. Well, howdy. Hi, I'm Alex Monahan. And my background is industrial and systems engineering from Virginia Tech. And then I just got bit by the data bug. So I spent 9 years at Intel breaking into data. Spent a couple of those years as a SQL Server jockey writing stored procs, as one does. And then in 2021, I discovered DuckDB. And I just became a huge fan, tweeted a lot about it, and started working part-time for DuckDB Labs. First on documentation, later doing some blogging. And for the last 2 years, I've been at MotherDuck. I'm a customer software engineer, so working with the folks using MotherDuck in prod. So what can we help with today? What can MotherDuck help you with? And it's really to avoid the big data tax. So what is the big data tax? Well, when the current crop of cloud data warehouses were created back in 2012, hardware was really wimpy. It meant to get anything done of any size, you had to split one SQL query up to many, many, many compute nodes. And to do that comes with a ton of overhead. You have to schedule that, plan that, route that. You have to shuffle your data back and forth over the network multiple times. And all of that has penalties. Penalties in terms of latency. Small queries take much longer than they should. They come with penalties in terms of cost. All those network hops are not free. And so we believe that this architecture, that it's time for it to change. Diving a little bit deeper, there's kind of 2 levels to this. We coined the term at our company of big data is dead. Well, there's a couple pieces here. There's the big data part, and that's fairly solved by object storage. You can kind of store about as much data as you want. It's not super expensive. It's OK performance. That's not really the main problem. The main part that is really painful, where the tax really comes from, is big compute. If you have to process data across multiple nodes, that's where you really feel and pay that tax. It just happens that big compute is dead is not as catchy as big data is dead. But that's what we're talking about.
Yeah, so this is I want to make that visual what Alex was just talking about, which is what we kind of notionally call the data singularity. For those of you who have seen kind of talks maybe from Hannes at DuckDB Labs, we believe we are there at the point of that arrow. And that is the theory that our ability to generate data has been eclipsed by our hardware's ability to handle that data, right? And that kind of sounds ridiculous, but Alex, if you want to go to the next slide here, we have a very timely tweet. Actually, this is, I think, from almost 2 years ago now from George Fraser. Hi, George, if you're out there. Most of our queries are not that big, right? I think like the P99 is like 256 gigabytes. They're not that big. So this is where we got to. And this is kind of the reality that DuckDB was built into. And I think the question that we're asking at MotherDuck is maybe we don't need these MPP systems anymore.
And so that takes us to DuckDB. What is DuckDB? Well, DuckDB was designed to take a single node and to push it as far as possible in terms of performance. It is an in-process analytical database, which means it runs inside of another language, inside of another process. So in our case, it's running inside of Python right next to DBT. It is open source, so it's MIT licensed, so you can use it for anything you'd like. And it's really, really lightweight. You can install it with just a really quick pip install. It'll take a couple seconds. It's 20 megabyte binary with no dependencies. And then in 3 lines of code, you're querying any CSV you can imagine. So one of the key things about DuckDB is that form factor. It's just so ergonomic, so easy to use to get started with. It's really lightweight. But it's also fast. When we say also fast, we mean for analytics, it is really fast. If you look at ClickBench, one of the industry-leading benchmarks for measuring analytical database performance, DuckDB is now #1. So when we say we're fast, we mean it. We beat ClickHouse on their own benchmark. Other notable databases on that benchmark include Snowflake, Redshift, and BigQuery. Right? So we're right up there with all the big dogs to prove to you that you don't need the tax that they come with. So what is DuckLake, and how does that relate? DuckLake is an open table lakehouse specification. So it's similar to Iceberg or Delta Lake. It's open in that anyone can implement it. The first implementation is a DuckDB extension. So that's where we're starting. So let's look a little bit at the lineage, comparing and contrasting data warehouses and data lakes, kind of talk about how we got here, and that'll help explain DuckLake. So initially, after we had traditional transactional databases, the first databases designed for analytics were created, data warehouses. They had a lot of scaling challenges, and they also used proprietary data formats that kept your data locked up, and it meant they could charge quite a lot of money to do it. Enter data lakes. Data lakes bring open formats like Parquet and Orc, and they use distributed file systems like S3 to have a very open approach to storing files. But they have challenges with concurrency. They have challenges with consistency. And they frequently became data swamps. Data lakehouses were created to address this, where they have extra metadata files on that object store to try and prevent corruption when there's concurrent operations going on. And that's borrowing from databases, borrowing those kind of ACID principles back from databases. Cloud data warehouses borrowed some back from data lakes, and they separated storage and compute, and they use object storage similarly to store their data files. But a key feature that we don't talk as much about, a key innovation there, is that to manage the metadata, they use a transactional database. So Snowflake uses FoundationDB, BigQuery uses Spanner, and that allows them to handle the metadata in a database. So DuckLake is really combining the best of both. It's bringing an open lakehouse style format with Parquet and sitting on object storage, but it's using a transactional database for the metadata to simplify it and improve performance. So really getting the best of both.
So there's 4 things that I want us to take away here, like what should you know about a lakehouse and what it does. And Alex hit on a lot of these, so I'm just going to kind of cover them a little bit briefly here. But number 1, open data formats. You can kind of bring any compute to it. It's really important. Often partitioned for scalability, right? So we can break these pieces of our data into much smaller chunks. So then we're doing our scans. They're very much constrained. We can do high ingestion really easily. Just drop a bunch of data in there. And then there's some janitorial or optimization jobs that are running in the background to kind of make that easier to query later. And then the last thing is we have the ACID consistency guarantees. And what this really means is that you can have multiple transactions running at a time, and if there's conflicts, they will get rolled back and rejected. So there's 2 paradigms we can kind of talk about here. The one on the left is my left, is that your left? Okay, perfect. My left, the one on the left is Iceberg. You'll notice there's multiple layers happening in here, right? There's a data layer at the very bottom, that's Parquet files typically. And then we have manifests, and then we have metadata, and then we have our catalog on top. So we have all these complex parts. And as you add and you commit more and more data, it gets slower and slower, and there's more metadata overhead looking at what's in those files. On the right-hand side, we have what the same system looks like with DuckLake, which is just a database holding metadata, right? And like Alex mentioned, if this looks familiar to you, it's because this is the same architecture that Snowflake and BigQuery implement as well. So I think what we're trying to really get at here is this shows you how to get to something that's very complex but valuable into something that's a simple distillation.
You bet. And you'll notice those data files at the bottom are identical. So we're actually using the same data format as Iceberg. So it's one thing to talk about simplicity in the abstract, but how does that help me as I'm crunching data? Well, first of all, it really helps with the local development experience. How many of you have run an Iceberg Lakehouse entirely on your laptop? We have 1 person in the audience. You get a prize afterwards.
Come find us.
Yeah. Come find us. Yeah. Come find us at the booth. So that's 1, right? In 5 minutes, we're going to set up a DuckLake warehouse in 5 minutes, a lakehouse in 5 minutes. So truly an unmatched local experience. You can also use it for CI/CD and testing. So it's not just that first initial setup where you get a lot of benefit. It's every time you're doing development work. It's every time you're running a test or a CI/CD deployment. Not only that, the simplicity actually adds to performance. All those layers that Jacob was talking about, those are all round trips back and forth to object storage, which is not fast. With DuckLake, it's one database request to a fast transactional database, and then you go read your files. So it's faster to read and write to DuckLake. And because we have the same data format as Iceberg, you can use one function call to import directly into DuckLake and another function call to export directly back to Iceberg. So it's incredibly easy to adopt for those extra simplicity and performance advantages. There's lower maintenance. It's a little, you can have, if you had 1 million metadata files on Object Store, it'd be a little easier to have 1 million rows in a Postgres database. Slap a B tree on there, good to go. We also can support multiple languages. Because we are a DuckDB extension in our first implementation here, DuckDB is so portable it can go everywhere. You can run it in Python, you can run it in Node, you can run it in Go, Rust, and in Java. So it's not locked into the Java ecosystem. It's anything that can wrap DuckDB, and that's 15 or more languages.
Great. So I'm going to put us in context real quickly, and then we're going to jump into a demo. So this is what we're going to show you today. We're going to generate some data using TPC data gen. We're going to then connect to that with DuckDB. We're actually going to ingest it. We're going to use dbt to load our data with DuckDB. And we're going to transform it with dbt and use DuckLake kind of in the back end. So these are the components. This is it. This is all you need to build a data lake. So shall we jump in? OK. Let's see if the demo gods are kind to us today. All right, so the first thing I'm going to do, as I discussed, is we're going to generate some data. I am using this handy TPCH gen. We're using the TPCH data set, which is a benchmarking data set. I'm also using UV. How does that look for size for those of you that are in the back? OK, see thumbs up. OK, great. Let's run it. So you'll see what's happening here is we're just getting Parquet files populated here on the left. Great. We just generated at scale factor 10. This is about 10 gigabytes of data. In uncompressed CSV, it's a little bit less, obviously, in Parquet. So we generated our data. The next thing we're going to do is actually connect to our DuckLake using DuckDB. So I'm going to just open my terminal. And I'm going to make this slightly bigger. Run DuckDB. So you can see I'm connected. And I'm going to attach my DuckLake. So this is what it looks like to connect to my DuckLake in my DuckDB. And now I'm actually going to start my UI as well. So I'm going to do call start UI like this. And it should pop open a local server looking at our database here. So what I'll show you is on the left, we have our databases. So this is our DuckDB running locally. We have our DuckLake, which has nothing in it at the moment. We have our memory database, which is also empty. And then we have our DuckLake metadata database. Now this is actually running Postgres. So when I connected to Postgres, and I'm viewing it with DuckDB. So we can actually just look at our snapshot table, for example. If I hit Command-Enter, so we can see it's empty, which is great. That means my setup worked. OK, so now we're going to jump back here. And how do we get this data that's sitting in this in these data files into our DuckLake? Well, let's take a look at our configuration. The first thing I'm going to show you is this is what our dbt profile looks like. Right? So we have our DuckDB type. We've got our threads. Right? We can run on 4 or more. We have our extensions. We have our secret. It's just a set of meta keys that we're going to use and pass to our Postgres database for authentication. You can also use environmental variables in here. I'm obviously running it all locally for the sake of this demo, but you can use any Postgres database here. And then I'm attaching right here. So a couple things that I'm defining here. The attach notion is kind of like a foreign data wrapper in Postgres or a link server in SQL Server. I'm defining a data path, and then I'm saying, hey, use these secrets up here to connect. So that's the first thing I'm doing in my profile. The next thing I'm doing is I'm telling it what database to use. So when I open my profile this way, I'm using an in-memory DuckDB database as kind of my core compute engine, but I can tell it where to write. And so I'm telling it to write into the catalog here in my config. This is probably pretty common for those of you who have used dbt this way, but just calling it out. The last thing I'll show is in the models, I have a sources file that just tells me, hey, like, here's my location of these files. And so now I can just reference them with DBT to load them into my lakehouse. So that's it from that perspective. And so now we can just run our DBT project. And so I'm going to do this, and then we're going to tab over here. And we're just going to see that our data is now coming in. Right, so we've loaded all that data, and you can see here now the queries are populating. We go back here, we can see DBT ran. And so now we have, in 10 seconds, we've taken this data, this raw Parquet file, and loaded it into our data lake. So now I'm just going to rerun this just so we can look at it. Perfect. So we can see we have our snapshots. So there was 32 objects built, so we wrote 32 snapshots. Of course, I can create it just like a database. Because I'm using DuckDB SQL, I can do fun things like write my select after my from, which is a fun party trick, I think. So there's that. And then, of course, we can interact with it just like we interact with anything else. So I can, like, for example, OK, thank you for the update cursor. We can do this, where we use our DuckDB in the command line. It's at the very bottom of the screen here, but to pass a query and just look at the raw Parquet files, right? So this is all showing these interactions. Because we're using DuckLake, we can have multiple DuckDB processes running at once, and they're not conflicting with each other, which is really cool. So one thing we love about data lakes is we can, of course, rerun our jobs whenever we want. So let's run it again. UV run dbt build. So when I run it again, one thing I'll show you is that we'll notice that we now have duplicated Parquet files for every file that we loaded into our data lake, right? Because the default materialization in this case is just a table, right? We're rewriting full tables. That's the normal DBT kind of workflow. And when we do that, the delete is a metadata-only operation in DuckLake, right? So we're just saying, hey, these files, just mark them as totally deleted, and then create new ones. And we'll point to those instead, right?
And it gives you full time travel capability.
Right.
That's the big benefit.
That's right, yeah. So you get time travel kind of baked in. But of course, what this also means is we've got a bunch of data in here that we kind of need to maintain a little bit. And so how do we do that in an easy way? Well, I wrote a little macro, which has a lot of Jinja and not very much other stuff. But there's 3 things we really care about in this macro, which is, I'm going to highlight them here and we'll go through them. The first thing we have is this call for merging adjacent files. Right? So what this does is it looks at the data that's been written in and puts them together. In this case, we're not going to do anything because we didn't write any small files, but you have it there. We can also expire our snapshots. For those of you who used Iceberg works the same way. You expire your snapshots and then you do your delete operation second. In this case, I'm actually setting this to 1 minute. So anything that's older than 1 minute, I just want to expire. You can set that to whatever you want, depending on your retention rules. And then we're going to run the cleanup. And then what the cleanup does is say, hey, once we mark these for deletion, let's actually do the delete. And because we put this in a macro in DBT, we can simply invoke it like this. UV run, DBT run operation, maintain DuckLake. And we will see in our data files that now we just have one representation of each query and one file for most tables. The line item table is actually partitioned, so it's split up in files, but everything else, we just see one. So I think that's it we had for the demo. Anything else you want to call out, Alex?
I mean, 5 minutes, and we've got a lakehouse on your laptop. Easy peasy.
Perfect.
Sweet. So that was Hello World. You guys could do Hello World anytime, pretty quick. We also wanted to talk about production. What does it look like to actually run this in the real world? So we've been working with a customer where they were running a 5-server cluster with 5 of the biggest machines you can rent on AWS, running Trino, a distributed compute engine, with Iceberg as the storage layer. And they were able to replace it with one serverless Duckling running on MotherDuck and DuckLake. So really dramatic scalability advantages. And to do this, it was a metadata-only migration. They didn't have to recopy all their data. So all the time that gets invested in centralizing data on Iceberg, you still get to benefit from all of that, but then get the simplicity and speed and performance advantages of moving to DuckLake instead. What are some other things that I need to run this in production? The first thing that I'm going to need is I'm probably going to want to run some compute in the cloud. You could run this all on your laptop and object store, but you're going to have to download quite a lot to your laptop every time you want to do something. So you're probably going to want to run some cloud compute. If it's serverless, it's going to make your life easier. You don't have to maintain clusters. Every once in a while, though, you're probably going to want a really big compute instance. If you need to repartition your data or resort your data, or scan the whole data set and aggregate it for a data science workflow, sometimes you really do need a lot of beefy compute. So you don't want to run this on like a Lambda with 10 gigs of RAM. Sometimes you do really need a lot of compute in the cloud. You're also going to want to lock this down, of course. Oh, and we'll get to that next. So you'll want to lock it down with access control. But you're also going to want to do some caching for better performance. So while S3 is bottomless and has a lot of throughput, it has a pretty high latency. So if you can cache things to avoid going to S3 every time, you get a huge benefit. And since lakehouses are immutable, once you write a file, it never changes, it's perfect for caching. And when you do that caching, you probably want to cache it across all your users in the cloud. Lastly, you have that scheduled maintenance. Again, probably don't want to cron on your laptop, probably want to cron in the cloud. So if you're looking to do that, MotherDuck does wrap this up in a convenient managed service. We can manage the full storage layer for you if you'd like, or you can actually bring your own bucket. And you can manage the storage and see all those files and retain ownership of your data and use us as the catalog and the compute engine. So we talked about large instances. How can we help with that? We like to call them ducklings of unusual size. So we have our mega. This is our Godzilla duck, as you'll see. That's 64 cores and 256 gigs of RAM. That's a lot of horsepower to throw at a problem. If you have a really tough problem, well, we've got our planet-sized duckling here, the Giga, which is the cutest icon we've got. And that is 192 cores and 1.5 terabytes of RAM, not to mention all the SSD storage that's attached. There are a lot of problems that fit in 1.5 terabytes of RAM, right? So you don't have to fall back to a distributed system. If you need it, it's there. So in conclusion, the combination of DuckLake and MotherDuck really make your big data feel small. And we do that by DuckLake being the simplest lakehouse by far. And if you want it even simpler, the MotherDuck hosted version will take care of some of those cloud-oriented pieces as well. We also made a lakehouse in 5 minutes. It's an unmatched local development experience. And when you want to go to production, you can have a serverless production environment that is similarly easy. And lastly, there are some lakehouse tasks where you do want a lot of horsepower. And for that, we have our ducklings of unusual size, because 1.5 terabytes of RAM will get a lot done. So how does that help me as a practitioner, crunching through numbers, doing analysis? It means that my existing skill set of DBT and SQL, I can operate with 10 to 100 times the data size. And I don't have to stand up a whole other stack. I don't have to learn a whole other language or have a whole other team maintain a platform on my behalf. I can just do it with DuckLake. And you can do it today with that instant import from Iceberg. So we want to say thank you so much for your time and attention, and we look forward to your questions. And we do have a couple of minutes. Do we have a microphone for the questions? I'll repeat them. Go ahead.
Sure. First of all, really cool shoes.
Thank you.
My question is, what exactly is inside of the DuckLake extension?
The question is, what is inside of the DuckLake extension? The DuckLake extension contains the logic for how to write the SQL statements to run against the catalog. So it's mostly just a collection of functions to communicate with your catalog and then write to Parquet files. The Parquet writer is another extension. The DuckDB compute engine is built into DuckDB, and then we have a Postgres extension if that's your catalog. But it's pretty self-contained, and that's by design, so it's easier to implement with other systems as well. That's a great question.
Yep.
Next question.
I was just curious if you could walk through your magic line of setting up the DuckLake. Just that one line that you ran. Was there other stuff that you were setting up beforehand, or was that literally all you had to do?
Oh, sure.
The question was, we had a magical line where we attached a DuckLake. Is there anything behind the curtain? What did we do before we did that step? And that's a very good question.
So the answer to that is very simple, is I just created an empty Postgres database, and once that database exists, I can use that attach command, and it will do everything else for me. So there's one thing in advance, which is create a Postgres database. That's all you need to do. Yeah.
We do have the option of using a DuckDB database or a SQLite database if you want to get it up and running on your local machine, but we expect Postgres for production.
Let me just see if they have the getting started here somewhere. Where did that go?
That's a great
Okay,
question.
there it is. I think it's right here. So like this is what it looks like for DuckDB. Here we're using Postgres, so it's a little bit more work. Yeah, it looks like this.
Sweet. You want to bump up the size? Zoom, zoom,
Oh,
zoom?
sorry.
Sweet. Other
There you go.
questions? Yes? What do we charge for a gigaduck? That one, you talk to us about it, and we'll hook you up. We do have our pricing disclosed on our page up to the mega. The gig is the only one we ask you to talk to us about it. We still think it's very price competitive, but talk to us. We're at the booth. Other questions? Yes?
I'm curious about BI tool connectivity.
Yes, the question is about BI tool connectivity. That's a great one. To connect to MotherDuck and to DuckLake, we use the DuckDB driver. So if it works with DuckDB, it works with us. That includes a wide variety of legacy tools. Sorry to say legacy, like Power BI and Tableau. I guess we can call them legacy. Can we agree? Okay, all right. Whew. And then some of the other ones as well, like Omni and Superset and Metabase. So there's open source options, there's commercial options, quite a few. But if you have one in mind, come see us at the booth.
Yeah,
We'll hook you up.
Yeah.
Great question. Next question. Yes. So the question was around the migration from Iceberg over. What did that look like behind the scenes? Great question. So there's, if you already have things in Iceberg format, there's a function called add data files. And you call that, and you basically just tell your metadata database about those files. And you say, hey, here are the files that I want you to consider. And you can just run that in a loop or run it with a long list of files. And you just tell the catalog about it, and then we're in business. So the files live where they are, in your own object storage bucket, and then you just tell the catalog about it.
Yep.
Good question. Thank you. Yes? It's an excellent question. The question was that part of the value prop of Iceberg is being able to use multiple compute engines. That's absolutely true. We address part of that by just having DuckDB already being able to run everywhere. So for example, Trino has a DuckDB connector. You can use that to access DuckDB directly inside of Trino.
Yeah.
We are working on a Spark connector as well to natively integrate so that Spark can also write to DuckLake. There's about a 30-line script where you can wrap DuckDB to do the same operation, even in parallel today with Spark, because DuckDB is so modular. But we absolutely want that to be the case, and it is an open spec, and it is mostly SQL-based. So we want to expand out to more transactional databases as well for the catalog, and then also more engines. But thank you. Yes? It's a great question. So the question was, is there a workflow that we can envision of having DuckLake be a local development workflow and possibly using Iceberg as a production deployment? You can, okay?
I can answer that. I mean, I think the answer is potentially. I don't think we have a reference implementation that matches that today. But I don't see anything that would hard block it at the moment. Yeah, I definitely happy to talk more about that too at the booth if you want to stop by. It's very interesting.
I do think that's something we're very interested in, of do all the really frequent transactional work with DuckLake and then publish to Iceberg for consumption for other engines.
Exactly. Some sort of way to do that.
We do see such an advantage on the right side for DuckLake that we think that we can publish and still keep the benefits of the Iceberg interop, but not have to pay the penalty every time you write to it.
Yep.
But thank you for the question. We might have time for one more. Lucky winner. All right, yes?
So, just curious, what are the benefits of still using MotherDuck instead of using the DuckDB UI? What are the things that you're still providing that are not included in the core offering?
Sure. So, we are a fully hosted platform, so we're serverless compute. Compared with local, the question was, how would you compare and contrast kind of DuckDB and then MotherDuck around it? So MotherDuck is the cloud data warehouse around DuckDB as the engine. So we love DuckDB. It's what powers kind of the heart of MotherDuck. we have a lot of things around it, like access control, user management, the ability to spin up multiple instances horizontally, the ability to have on-demand really large instances ready. We have a completely replaced the storage layer, and we have a caching layer on top. And then we also have a managed DuckLake service as well. So I think of it as sort of like single player to multiplayer.
Yep. All right, I think we're done. Thanks, everybody. We really appreciate it.
Thank you for your questions. Cheers.